Part 2, General Tech and Technician Classes. Same study question G with the General Technician class license. With the General class license, provide all amateur privileges except for the reserve of the advanced extra for the class of the license. General class examination consists of the 13 word per minute U code test, Technician 5 word per minute code test. Both classes require the written examination of the Federal Communication Rules. General amateur practice the regulation of the Technician class. License offered with the interest of the VHF, the UHF, higher frequencies, anyone with a representative of a foreign government eligible to apply for the class of the license. A written test concerned cover the general amateur practice with the regulations of the station operation apparatus provision with the treaties with the statute with the rules affecting the amateur station with the operators. The FCC exam cover the 8-section rules regulation radio phenomenon. 3 operating procedure. 4 emission characteristics. 5 electrical principles. 6 practical circuits. 7 circuit components. 8 antennas and transmission lines. 9 radio communication practices. In addition to questions of this part, you should be also familiar with the subject matter given in part 1 of the book. Novice class study questions and some of the questions that may appear with the general class exam. Chapter 8, Electrical Principles. So the term of electronics some will become the took with the nature used of the often enough in this section review of the basic term review of the electronic fundamental relation with the circuit theory, the experience with the electronic technician. The section may seem elementary, but the newcomers may strange as terms of the may appear. You should be able to receive the question regarding the data found in the FCC examination. Make sure that you understand what the definition principle given, the define with the term impedance, the term given in the AC circuit with the usually with the containment of both reactance and resistance with its measure of the ohms symbolized with the letter Z with the impedance of the AC with equivalent to the DC resistance. What is reactant? With the reactance is classified into 2 primary categories: inductive and capacitive reactance. Inductance reactance is the opposition inductance offered for the change of the current. A coil reacts as a current change by a generator counter EMF, which opposes the change of the current. Capacitive reactance, on the other hand, is the opposition of capacitation offers of the change in voltage. Opposition inductance offers for the change of the current and the self-induced voltage, or CEMF, measured with the volts over the how the opposition currently flow the normally measured in the ohms, not in volts. So the coil reacts with the current change of the generator of the counter of the counter EMF coil said to be reactive with the opposition of the coil there called the reactance X is measured in ohms. Some of the one kind of the reactance that exhibits subscript letter L is added to denote the inductive reactance. This opposition offered by the coil alternating current with the terms of the inductive reactance designated as X in capacitive inductance. Term inductive reactance is XL. Definition: capacity and opposed chain with the applied voltage. With the applied voltage chain with the capacitor charged with the discharge with the voltage capacitor is equal to the new with the value with applied voltage when the capacity voltage is equal to the source voltage with no current flows. Similarly, with the capacitor reef, the voltage of the chain with the produced by counter EMF, the capacitor is shown to be reactive. With the opposition of the chain with the capacitor is called the reactance. It is measured in ohms. In order to distinguish capacitive of the reactance from the inductive reactance, the subscript C is added to the symbol X. So C is for capacitive reactance. Inductive reactance is L. The opposition offered with the capacitor alternating current is termed of capacitive. The reactance is designated with the XC. In inductive circuit, with the current lags of the applied voltage with a 90 degree, with the capacitive with the current circuit with the current leads of the voltage by 90. Explain the term decibel. The term decibel, linear means of the expressing logarithmic change of the power and level of the international transmission unit of the bell, which is equal to 10 decibels. For the first definition of a decibel with 1/10 of the bell. The bell is its equivalent in a 10-to-1 ratio of power of the gain. Bell is number times 10, taken as a factor of the equal to the ratio of the output power of the amplifier any of the device input power. There's some convenient rule of thumb, but if you have to remember what you're measuring, voltage changes brings with the current changes in that in turn increase power levels themselves of the elements actually maybe to be compared with the decimal values, doubling any of the power same and increase the power 3 decibel with the having power value with the same and the decreasing power 3 decibel, doubling each voltage current with the result of the 6 decibel increase to become the voltage force of the double current as well, resulting in quadruple over the power. Each time the power is increased in an order of magnitude, the factor 10 of the gain is increased with a 10 decibel. The basic ratios are 1 million to 1 is the number of 10 factors, 6 is no bells, number of bells is 6, and you have the number of decibels is 60. Power ratio of 100,000 to 1. Number of 10 factors is 5. 5 zeros. Number of bells is 5. Number of decimals is 50. And then it goes on to 1 to 1 would be 0 factors of 10, 0 bells, no decibels. Was the effective value sin wave in the relation with the peak value with the effective wave of the most commonly referred to as REMS, root mean squared. Effective value sensational voltage current of 0.707 times peak with the value equal to the peak of the maximum value divided by the square root of 2 or 1.414. Average effective with the maximum value of the sin wave is shown in the graphically in 8.1. Defining the following describe the particular situation each might use the root mean squared voltage, peak current, average current, power, and energy. Root mean squared voltage of the term means root mean square RMS applied with the alternating voltage mean the comparison with and equivalent DC voltage value. The AC with the root mean square voltage required with the delivery with the same effects with the power load with the DC power source as U with the AC gained popularity with it became an increasingly apparent shown with a common basis. U with the AC with the DC with it was compared with a 100 watt light bulb, for example, should work just as well with 120 volt AC as does the 120 volt DC. However, the sim wave voltage having in the peak value of 120 volts would not supply the lamp with as much power able to save it as the 120 volt DC. Since the power dissipated with the lamp is resolved with the current from the lamp, the problem resolved with the one finding in the mean over the alternating current ampere is equivalent to steady ampere with the direct current to show the comparison between the various values that indicate with the value of sim wave of the voltage shown with the effect of the root mean square value of the wave, which is DC equivalent of 70% of the peak value. Your peak current is one of the most frequent measured characteristics sim wave. The amplitude of the alternating current over the voltage presented in the circuit must be measured in the various ways. When measure the maximum amplitude with either with the positive or the negative the alteration, measure the value of the current voltage of the time of the peak of voltage or current, measure the peak value of the current and voltage, oscillate with a special meter. Peak reading must be used with the peak value of the sin wave of the illustrated in figure 8.2 with a notice of value of the 100. Average values at 63.7. The root mean squared is 70.7. Peak value. Root mean squared. Measure of the peak current is often made on the antennas, transmission, audio circuit, radio frequency amplifiers. Your average current, average value of the complete cycle of the sim wave is 0 with a positive alteration, identical with a negative alteration. Certain types of the circuit, however, it is necessary to compute the average value of the one alteration. This can be accomplished by adding together the series of the instantaneous values of the wave between 0 and 180, then dividing the sum by the number of instantaneous values used. So the computation would show one alteration sim wave to have an average value equal to 0.637. The peak value shown in comparison sim wave figure 8.2 have average values of the current voltage useful calculation unfiltered output voltage current of rectifiers. The DC output unfiltered rectifier is equal to the average value of the applied voltage alteration. Show that the percentage of the peak is 0 to 100 decibel, 77.7 effective with 63 point average peak to peak. Power value. Power means of the measuring of the rate with which it is accomplished may be calculated purely resist the circuit with the multiplying load current by a source of the voltage. Source of the voltage known with the power with calculated with the multiplying square root current with the drain with the resistance of the load. The power is extremely common in measurement of the electron with the amateur radio, often with the principle of means of the measuring with a certain efficiency with the circuit performance capability with the requirements of sort of the adequate lead drive of the load of the watt of the unit electrical power with the equal to work done on the rate of 1 joule of the work per second. Types of inclusion and applications with the measure of the may include the transmitted radio frequency output shrink with the measurement of the output volume and almost unlimited number of the other functions both ANC and the DC energy. The term energy represents the ability to perform work electrically as appeared applied to an amateur radio. In other words, certain amount of energy is being available in order to the source to be able to deliver a certain amount of the power to load. Energy that is capacity to perform work of the basic unit, which is the dual practical uses of the term occur with the studies related with the nuclear physics and with the computing of the value of the larger discharge. A6 is defined with the term mutual inductance. Mutual inductance defined with the ability to circuit with a device to transfer energy with electrically isolated circuit a device, usually mutual inductance current and interaction of the two coils with the exchange of the current in one coil includes the change of the voltage in another adjacent coil. Defined the term of the permeability. Permeability measures the ease of the magnetic line forces of the magnetic strip of the term of the rough, comparable to conductance of the which indicate the ease of the electrical current flows of the conductor. 8.8. What is the unit of the capacity of the basic unit of the capacity is farad, the farad. So the basic unit of the capacity is a farad. The unit of the terrible impractical was practical value of the use very small with a fraction of 1 farad. The practice of the microfarad is equal to 1/1,000,000th of a farad, and picofarad and 1/1,000,000th of a farad are common with a nanofarad with a billionth of a farad is also common use. What is the unit inductance? The basic unit of inductance is a Henry. The Henry is not unwieldy and fair of the subunit is still with a more than common, particularly radio frequency. Subunits of the millihenry and the microhenry and the nanohenry. The meaning of the power factor concerned with the phase angle between the voltage and current circuit. Usually expressed on a decimal fraction of the percentage of the show of the power calculation. Ohm's law do not take with the reactance into the account power calculation. AC circuit result of the apparent power, which must be curved with the multiplying apparent power with the power factor. With the mean of the ampere turns, 1 ampere turn of the magnetic force of the required to establish the current flow of the 1 ampere through with the 1 turn of the wire magnetic field. To find the term inductance, inductance properly show the cover the impose of the chain of the current through it. But whether to describe the character of the inductance does not accurately define the term. Michael Farad discovered that voltage was developed and chain with the direction of the flux and lines of force. The amount of flux that links with the conductor to the coil phenomena he discovered what were referred to with inductance. Later experiments showed the magnet to the generated voltage is directly proportional to the rate of the conductor's cut with the magnetic line force, stated known as the Faraday's law. The rate at which conductor cuts the magnetic lines of force depends on the number of turns of the coil. Strength of the magnetic field shapes either the magnetic field or the coils move with wires move with parallel to the magnetic field with cut no lines of force with no voltage developed, cutting across the field at an angle less than 90 degrees. Result of the lower voltage than the wire were moved at the same speed perpendicular in the field. With the same the conductor moved at a constant speed across the magnetic fluid field. The uniform flux density of the 1 volt is generated every 100 million lines cut per second. When an electric motor force generated this way can be put in the formula electric motor voltage equal to the total flux cut by times the time of the seconds times 10 to the 8th. When the conductor consists of several turns of the coil of the wind of the magnetic field with a not uniform with a not cut in at the uniform rate of the formula becomes more complex. Polarity induced voltage is always the opposition force of the producer of the illustrated with the take of the wire of the coil wound and around. The simple formula is also shown in the figure 8.3. Across the coil connect with the galvan and meter complete the circle of this so that there were current flow over the voltage and due to the north pole over the magnet and over the center of the coil shown with the AMF. And due to the current over the will flow over the direction and indicate with the arrow labeled I. As for the external of the circuit is concerned, the induced voltage shown on the top of the bearing with the positive of the lower bearing and negative of the cover. The top of the nib of the coil do appear with the north pole, which are over the downward direction of the magnet. Induced polarity of the coil may also be the same if the approaching magnetic coil, otherwise would be necessary only to the chart of the magnetic coil of the coil. Upon inducing an opposite of the pole of the coil of the magnetic will be drawn with the inducing with additional of the EMF without work. This would be perpetual motion machine would provide the unlimited source of energy without consuming the energy in a condition on the contrary to the law of the conservation of energy. Next to considering a wire moving downward the length of the perpendicular magnetic field that runs left to right is shown in figure 8.4. Thinking of the lines just as though the rubber bands were wrapping around themselves around the wire. Lines of force of the would encircle the wire counterclockwise direction, cutting the lines of force includes, and the voltage along the wires over the currents over the circle marked with the X is considered. The cross-section of the conductor, the passive of the edge of the current flow would also be down to the page of what is the merit of the circuit, with the effective of the circuit, with the height of the merit of the circuit, effect of the bandwidth, the type of the magnetic field, the salvage of the sector, or the line of flux, and the energy loss for the ratio is Q, sometimes term referred to as the Cole figures of merit. The merit of the inductor is equal to the ratio of the inductor with the reactant effective of the resistance and shape of the approach is the high value of the resistance approach with the low value. The more effective of the coil, the lower the loss of the higher the merit. In terms of impedance triangle, the figure 8-5 of the equal of the tangent of the phase angle of the hypotenuse of the impedance, the time times the base of the resistance. And show the X, the capacity of the inductance of the impedance, and impedance triangle, the resistance. Show the currents ampere from 0 to 1, the merit 100 of resistant of ohms, 110 ohms, 707 the peak current, and 404.47. A phase angle approach over the 90 degrees tangent approach over the infinity of the coil loses approach over the zero. With the merit over the coil does not vary very extensively within operating alignments with the circle, it would appear seem that the merit of it is equal to the inductance over the resistance of the single inductive resistance reactance of the directive of the function of the frequency of merit also may be the direct function of the frequency, such is not the case if the true of the frequency increase the inductive of the reactance increase of the frequency increase the effect of the resistance will increase the same of the merit with the inverse function of the effect of the resistance and not effect of the frequency increase of the leave of the merit with a relatively unchanged. The higher the merit, the sharper the bandwidth. The circuit of the merit is lower with the amplification resonance of the very small, but the circuit that does not discriminate sharply between resonant frequency and the frequency of the either with the resonance is shown on the lower of the curve of the figure 8-6 with the range of the frequency included between the two frequencies at which the current drops at 70% of the value of the resonance is the bandwidth of 70% of the response with the current of the 70% maximum and the power 1/2 of the maximum. Hence, the bandwidth is often referred to as half power bandwidth. Frequencies beyond 70% of the half power point are considered to produce a non-unstable, non-usable output. Series resonance circuits are seen to have the two half-power units, one above the resonancy, one below. 2 points are designated upper cutoff in frequency and lower cutoff frequency. In figure 8-7, these points are labeled F1 and F2 with a range of frequencies between the 2 points compromised with the bandwidth. The figure 8-7 illustrates the bandwidth as a high, low, and merit. Series resonance circle of the bandwidth may determine the equivalent bandwidth of the frequency 0 over the merit of the bandwidth may be determined by the equation bandwidth frequency over 0. Center frequency divided by a circuit of merit with the bandwidth also determined with the subtracting low cutoff of the frequency upper cutoff frequency or bandwidth is equal to frequency 2 over minus frequency 1. Term bandwidth band pass sensitive of the mouse cells will be applied to resonant circle because of the shape of the resonant curve. Describe the impedance variation with respect to the frequencies of the same as the general structure of the curve of the use of the sum of the series of the resistant curves. Curve of the high merit and low merit circuits are shown in figure 8-8. Notice that the high merit circuit is selected with the good with the low merit curve of the wire bandwidth. Henceforth, the power selective comparison permitting overall merit of each of the curves cannot be made by each of the curve that has advantage of the disadvantage applied with a particular circuit. 8.14. What is resonant frequency and how is it determined? Resonant capacitor and inductors are determined with the physical construction applied with the frequency and inductancy. Their capacitive inductancy with directly frequency capacitive capacitancy varies inversely in frequencies due to the relationship combination inductance and capacitancy have specific frequency of the reactancy will be equal to the inductance capacity of the inductive capacity and capacitation frequency and resonant frequency shown in point F0 or shown in figure 8-9. Interiors of the resistor, inductor, capacitor circle with the largest reactance value determines the appearance of the phase angle of the circuit. Will it be figure 8-9 below the resonant frequency of the larger frequent reactances above frequency merit of inductance large reactance. The first circuit with a capacitive of below merit 0, inductive above merit 0. Equation determination resonant frequency can be developed in the following manner. At resonancy, resonant inductancy is equal to resonant capacity, substituting equal inductancy and reactancy. 2 pi times frequency over the inductancy equals 1 over 2 pi times the frequency of the capacitancy. Transposing frequency 2 is equal to 1 over 4 times pi over the squared times the inductancy capacitancy. And for F, the frequency of the merit is equal to 1 2 pi times of the square root of the inductance and capacitancy in farads, in hertz, and frequency. Capacity of reactance series computed. The capacity of the reactance and series of the pair well can be due with a much the same on the resistance of the series of the pair well to the capacity of possessing 25 ohm reactance connected with the series of the 2 reactance of 50 ohms. The same 2 reactance connected pair well, the total reactance would be 12.5 ohms in the equation form of capacitancy T, total capacitancy, total C, capacitive capacitancy 1, 2, 3 plus to the number term. For parallel capacitancy total will equal to 1 over capacitancy 1 plus 1 over capacitancy 2 plus 1 over capacitancy 3, the capacitancy number terms. And figure 810 shows the graphic question 8.6.8.15. Example of the circuit is opposed to the 810 example of the circuit are asked to determine the total capacity reactance between X and Y. Use the sample method analysis with the resistor solve the capacitive equation between C2 and C3. The capacity of the equation is equal to 1 over the capacitor 2 over the capacitor 3. Which is 17.5 ohms. Determine the capacity of the total between X and Y. A capacity of 1 times 4 times capacity of the question, 50 times 103 plus 1750, 170.5 ohms. Illustrate the relationship with the capacity of the reactive of the current frequency, ACP's capacity of the circuits. Analyzing the graph showing the frequency increases, capacity decreases, current increases with the high frequency capacity with a low opposition current with the frequency increase of the capacitor characteristics approach those short circuits. On the other hand, when the frequency decreases of the capacity and increases of the current decreases at points marked as 0 frequency represented with the DC capacitor exhibited with a characteristic open circuit with extremely high opposition, no circuit current. 8.16. How inductive reactance series are computed. When the series connected in the inductor shield with the locative of the far enough to make the effect of the mutual with the inductance with the negligible equivalent total inductance of the circuit with the algebraic sum individual inductance expressed mathematically is the total inductive is equal to L1, L2, L3 plus L to the nth term. Pair well where L total is the total inductancy in Henry, L1 is the individual inductancy in Henrys. Pair well connected inductors total inductance and total inductance calculated the same for the total resistors. Pair well calculated provided for coefficient coupling with a 0, but there is no mutual indication of these indicators connected with the pair well with the reciprocal total inductancy equal to sum of the reciprocal of an individual inductancy mathematically shows 1 over the inductance total is equal to 1 over the inductance 1 plus 1 over the inductance 2 inductance 3 into the total of the nth term. With the total inductors parallel with no magnetic coupling over the sum of the method employed as 1 over the inductor over the inductance of 1 plus 1 over the inductance of 2 plus 1 over the inductance 3 plus 1 over the inductance of the nth term. Where there are 2 inductors is parallel with no magnetic coupling provided over the sum of the maybe employed with this inductance totals inductive 1 and 2 multiplied times over the inductive 1 plus inductive 2. The formula inductive reactance circuit is given in the inductive capacity. Capacitive inductance of the 2 times pair pi with the frequency of the inductancy. Frequency is implied in the hertz. Inductancy is in Henry's. Terminally inductive resistance reacting with the wedge of the knob of the inductors here with the parallel of the must first calculate the value of the inductance indicated above. The application formula inductive of the reactant with the correct answer to be obtained. 817 the voltage drop the cover the individual capacity with the series string with the when the string with the place across the source of the voltage proportional to what factors? Inversely proportional to the number of the identical capacitor within the string with the 2 capacitor with the 1 capacitor develops half of the total voltage of the other 3, each capacitor 1/3. etc. The defining the term reluctancy. Reluctance is defining the opposition of flux and magnetic circuit of the throw, comparable to resistance DC, the quantity of the basic unit of reluctance, REL, the reluctance magnitude circuit 1 centimeter long with a 1 centimeter cross section permeability of 1.0. Mathematical expression of the reluctance in REL is length divided by the permeability time the area. Reluctance is equal to the 1 times the permeability cross-section area. What factors determine the change of the charge stored in the capacitor? With the table of the formula charge of the equal capacity time of the voltage, it must be simple. Several factors to determine the capacity with too much of the factors influence of the total charge. Some of the higher the electrical constant, but the greater the stored charge merit. The charge depends on the capacity area of the plate, the distance between the plates, the electrical constant, the applied voltage duration applied with the voltage equation of the charge of the merit of 0.2246 E. Volts or kiloamps over D. E is the voltage, X is dielectric constant, A is the area of the plates, and D is the distance between the two plates. You're given the two identical microcompactors of 0.1 picrofarads, one charge potential 125 volt, disconnected from charging circuit with the charge capacitor is then connected to the pair well charge 1. The voltage will appear across the pair. Voltage cutoff of the two will approximately half of the total voltage first capacitor make of the connection uncharged capacitor with the discharge of the charge 1 while actually being charged with the voltage equally distributed between the two capacitors. The ultimate charge of the slightly less than 62.5 volts because of the act of charging the capacitor takes a small amount of energy. 821. How effective is the change of the resonancy of the power is defined as a rate of the during with the rate of the expanding of the energy with the electrical power and loss. Power was found with applying the following formula. Power is equal to amps times volts. Power is equal to amps squared times the resistance. Power is equal to amp squared volt squared over the resistance. They can see the change of the resistance will affect the power. So the increase of the resistance will increase the decrease of the power, and the decrease of the resistance will increase the increase of the power. What is Kirchhoff of the voltage law? Of the Kirchhoff of the extent of the use of the Ohm's law of the developing simple the concept of the concern of the voltage contained in the series circuit loop. Study of the algebraic sum of the instantaneous electromotive force volt drops in any closed circuit loop is 0. Thus, the Kirchhoff law circuit problems can be solved with the difficulty imposed only with the knowledge of the Ohm's law. When the laws are properly applied, any equation can be set with a closed loop with an unknown circuit value may be calculated. Curve shape of the current law of the division of the current is parallel with the network file with a definite pattern of the pattern is described by the Kirchhoff's current law. Algebraic sum of the currents of the entering and leaving any junction of the conductors equal to 0. The laws can be stated as inductance to the plus A plus L to the length is 0. All currents of all inductive currents, ampere currents are currents of the entering and leaving the junction. Currents entering the junction with a measure of the positive. Currents leaving the junction with a consider of the negative. When solving the problem of the equation, the currents must be placed into the equation when the properly polarity sign is attached. 824. The current determining the parallel of the resistive with the inductive of the capacitor network is the parallel and inductive with the capacitive with the inductive with the capacitive with the capacity. Parallel network voltage of the component with the equal with the apply of the voltage of the current with the inductive of the branch lag with the apply of the AC voltage 90 degree over the current capacity of the branch will leave with the apply of the AC voltage of the by 90 degree with the result of the two reactive components tend to cancel each other without call with the net combined current with the flow to 0. Therefore, the only current flow through the circle of the root of the resistive element is inductancy equal to capacitancy with a parallel circle referred to as parallel resonance. Inductive reactant with capacitive reactance if it not equal to the current flow of the circuit is calculated with the current vector method of the admittance method. 825 with the impedance parallel circle of the pure inductance of your capacitancy at resonancy of the series circuit of the at a resonancy. In an ideal parallel resonance circuit with a line current with a 0 with a sense of the impedance of the equal of the applied voltage divided by the circuit current, which is case 0 and impedance must appropriate infinity. In this year, the resonance circuit with the impedance is equal to the resonance with the circuit with the pure capacitancy, pure inductance, no resistive element resistance can be summed by 0 with the near of the 0's likelihood to cause 0. Determine the resonant frequency with the RLC circuit with the consisting of the 8 picrofarads capacity of the 10 picrohenry coil and a 10 ohm resistor. The calculations differ with a parallel resistor inductive capacity circuit. Solving the problem, we have farads at 0 is equal to 1 over the 2 times 5 of the square root of the inductive capacity. Farads frequency 0 is equal to 1 over 6.28 times square root of 8 to 80 times 10 times 10 to the negative 12. So we get frequency is equal to 1 over 10 to the 6 to the 1.77.5 or 5.63 kilohertz. Frequency of 5.63 kilohertz applied with the circuit of the bath and inductive resistance reactance will be equal to the form of the determinant resonant frequency of the resonant inductive capacity of the chamber that one used in series circuit. What is the impedance matching between the electrical device? And an important factor of it is always the desire that it can always be attained, but in practice the transfer of the power of the electrical source of the load of the impedance of the load must equal the match of the internal impedance source of the maximum transfer power signal of the DC circuit of the table of figure 812 of the illustrative of the principle a 10 volt battery. Internal resistance of the 1 ohm feed of the external circuit of the variable of resistance of the resistance 0. Resistance 0 is at 4 ohms. Total resistance circuit with the 5 ohms resistors B and O with the current of the circuit with the 2 amps of the voltage drop is 8 volts. The power is absorbed by the load with the equal voltage impedance with the times the amperage with the 16 watt with the power of the distributed with the battery heat of the voltage S voltage B multiplied by the amps of 4 watts. The result resistance of the 3 ohms, the total resistance 4 ohms, 2.5 ohms of the voltage of the inductance is 7.5 ohms. Power absorbed with the 18.75 watts by the battery with the 6.25 watts. Resistance of the 2 ohm of the total resistance 3 ohms and amp is 3.3 amps voltage and inductance 6.66 volts. Power absorbed with the load 20 watt with a battery with a 10 watt with a resistor arm with a 1 watt with a total resistance 2 amps and 1 amp is 5 amps. Total voltage inductance is 5 amps, 5 volts. Power absorbed with the load with a 25 watt battery, 25 watt. Resistance at 0 is less than 1 ohm. Power of the falls off of the load with an indicatable in the table. The greater the power of the delivery, the load impedance will equal to the internal impedance source. To answer the question of the impedance matching between the electrical device, important factor of the given with the percent of the total power delivered to the load with the always with the desire with the power transfer the creation of the circuit performance. Unfortunately, can always be achieved with the practice of the input with the impedance of the frequency dependent with the 4 ohm speaker with the audio circuit, for example, the only precisely method of the amplifier at 1 frequency. Explain the operation of the transformer. Operation of the transformer depends on the electromagnetic induction, basically transfer of the consistent of the 2 inductive separate circuits. Plays physically of the change of the electromagnetic field set up with the alternating current of the one and do with the alternating electromagnetic force is in the other. Mutual and inductive exhibit between the coil of the 2 circuit of the use of the inductive couple will show the basic transformer will connect with between the AC gem with the resistant load. Coil connecting source with the power of the primary winding. The coil with the connect with the load called the secondary one, and the power to deliver with the generator pass with the transformer delivered to load. No directional connection between existing between the primary and secondary one between the generator load with the connection that does exist. The flux linkage between the coil and the power to effectively transfer by the induction. Thus the power consumed with the primary is equal to the power delivered by the secondary with the power, and the primary is equal to the primary and secondary with the coil of the transfer. Completely shield from each other. The no power with the transfer could take the place of the transformer would be useless. 829. The most important factor of the existence of the transformer, the factor of the be considered the design of the obtainment of the maximum transfer or efficiency. Maximum transfer of the power primary to the secondary of the transformer, the flux line linkage must be complete. All of the lines of forces set up with the primary windings must link with the secondary winding for the reason secondary with the often front wound. Direct with the primary with the only protective of the insulation separating with the 2 coil with the reluctance of the air with a very quiet great is permittably small with the induction soft steel with the core or high permeability transfer with the increase of the flux linkage between the coil with the maximum possible high percentage of the power transfer, even in the use high permeability cores of a few flux line with the field of link secondary winding with effective loss constitute with the flux linkage, which prevents transformer from being perfectly conductive of the power of the generator load. Practical iron core transformer does not cause, not of course 100% efficient when carefully designed to show that the high efficiency is ranging from 95 to 98%. High efficiency is probable to transform to become the careful attention of the devoted to minimize effective loss of the due to the flux flux leakage, hysteresis, eddy current, flux saturation of the core, as well as the core, loss of the coil, with the winding, loss of the distributed capacity. However, the number of turns ratio of the fact of the secondary voltage transformer, the magnitude voltage induced with either side of the transformer depends whether directly upon the number of turns of the back of the EMF induced. The current change in current primary did not equal EMF induced on the secondary, and lift the number of turns in primary equal the number of the secondary. But furthermore, since the back EMF of the back primary is equal, applied voltage ratio becomes instead of determine the electromagnetic force induced with the secondary in terms of applied voltage terms ratio to coils. Therefore, voltage in the primary voltage applied to the primary is equal to the number of turns in the primary, and voltage in secondary and primary is equal to the number of voltages in secondary. To discuss Lenz's law with respect to the induced EMF. Lenz's law states that induced EMF always has such a direction of the action when it produces this current with the flowing with a circuit varying with the magnitude produces very magnetic field which set up the induced EMF for the purpose of the current changing of the producing it, or maybe said that the current in circle that increase with the induced EMF as opposed to the applied voltage tend to keep the current from increasing when the current is decreased with induced EMF at the edge of the line. Voltage tends to keep the current from decreasing. If ever the counter EMF may be observed with experimental with the alternating current through the inductor probe with the force of the motor grade with a simple DC with a resistance DC resistant primary ordinary power transformer using typical application may be 5 ohms. The figure 814 primary connected with a 115 volt AC from the Ohm's law, amperage with the equal to voltage over the resistance, which is equal to 110 over to 25, with over the amperage is 22. Use the approach of the current is calculated 22 amperes of the measure of the current with actually found with approximately 1 ampere. There is apparent such opposition other than the 5 ohm resistance present with the AC with the circuit with the opposition with the counter EMF with the next state with the transformer connected with a 115 volt DC line. Current of the primary transformer would be 22 amps, and when the transformer would quickly burn up. However, hence Ohm's law of the DC circuit made modified it to include with the effect of the index electrical inherited present with the AC circuits. If capacity, reactancy, series resonance circuit with 200 ohms and a resistance of 10 ohms, the circuit would be 0 will be E, 200 ohms. Chapter 9, Circuit Components.